Hello guys, good afternoon. You are welcome to my YouTube channel, The Explicit Tutorials. Please, as you are watching this video, endeavor to subscribe, like, share, and comment. And of course, if you know you haven't watched other videos on the various topics we've treated so far, I will advise you to do so for a better understanding. So in today's class, we shall be discussing state of matter in chemistry as one of the striking topics in the world of chemistry. And of course, we all know that there are three states of matter. We have solid, we have liquid, and we have what? Gas. These are the three states of matter, and they have their own respective characteristics or properties. Now, solid, of course, has definite volume and what? Definite shape. Solid has a definite volume and what? Definite shape. That is for that. That is number one. Number two is that they have strong force of attraction. They have strong force of attraction. That is why solid molecule is very, very hard, because its molecules are strongly joined together by strong force of what? Attraction. Please take note of that. It is very important. Owing to the fact that the molecules are strongly joined together, it means that the rate of diffusion in solid occurs at the slowest rate. All right, because molecules are joined together compactively, so it means that they don't diffuse easily. All right, so diffusion occurs at the slowest rate in solid. Then liquid, on the other hand, has definite volume, no definite what? Shape. No definite shape. It has definite volume and what? No definite shape. All right. It therefore means that liquid takes the shape of what? The container. Any container it is found, it takes the shape of what? The container. Please, the force of attraction found in liquid is not as strong as the one found in what? Gas. So you see the force of attraction found in liquid is what? Moderate, all right? And it is not as weak as the one found in gas. What about gas? How will you describe gas? Gas has neither definite volume nor definite shape. And gas possesses a type of motion called what? Brownian motion. In this type of motion, the gases move irregularly or zigzagly, bombarding the walls of the container. So please take note of that. Gases do not have definite volume nor definite shape, all right? And they possess Brownian motion or a zigzag type of motion. And secondly, the rate of diffusion in gases occurs at the highest rate, because the force of attraction found in gases is what? Negligible. If I don't use the word negligible, I'll say it's what? Insignificant. The force of attraction found in gases is negligible or insignificant. That's why the rate of diffusion in gases occurs at the highest rate or at the fastest rate. But in solid, it occurs at the slowest rate. So please, these are the characteristics of solid, liquid, and what? Gas. Now, in this topic, our major concern is just on gases. So I'll write out ideal gas. Ideal gas. Now, what are gases? You see, gases are substances that expand to fill the container in which they are found. I will take it. Gases are substances that expand in order to fill the container they are found uniformly. All right, gases are substances that expand in order to fill the container in which that is uniformly in which they are found. So in gases, there are different terminologies used in gases, or you say there are different variables used in gases. One of these variables is volume. Now, how would you describe volume? You can say volume is an empty space or a container in which a given matter is what found. It's an empty space or a container in which the gas is found occupying. All right. Volume has different SI units. All right. It has what is called the cubic centimeter, or the cubic meter, sorry, cubic meter. Cubic meter is denoted as what? M cube. Cubic meter is actually too small, or actually is too large. Cubic meter is too large. It therefore means that scientists don't commonly make use of this SI unit. They make use of other smaller units such as cubic centimeter, denoted as cm cube. Another one called cubic decimeter, denoted as what? dm cube. Another one called what? Liter, denoted as what? L. So these are the various SI units that can be used to denote volume. However, this first one is not commonly used because it is quite large. Now, take note of this. 1 liter is equivalent to 1 cubic decimeter. 1 liter is equivalent to 1 cubic decimeter. It is equivalent to 1000 cm cube. That is, you can say it is equivalent to 1000 cubic decimeter. This is also equals to 1000 milliliter, and this is also equals to 10 raised to power minus 3 cubic meters. 1 liter is equivalent to 1 cubic decimeter. 1 cubic decimeter is equivalent to what? 1000 cubic centimeter. 1000 cubic centimeter is equivalent to 1000 milliliter. 1000 milliliter is equivalent to what? 10 raised to power 3 minus 3 cubic meter. Take note of that. So these are the units of what? Volume. So the next variable that can be used in gases is pressure. All right, pressure. We don't say pressure. Pressure. Now, how would you explain pressure? Pressure means the force exerted. Pressure means the force exerted on the surface of a given material divided by the area of that material. I said pressure is the force exerted on the surface of an object divided by the area of that object. Force over area. That is what? Pressure. Pressure also has different SI units. You have one of the units to be Pascal, which is what? P small letter what? A. However, Pascal is too small. It's quite a small unit. So we don't make use of Pascal. Scientists commonly do not make use of Pascal. So they make use of other units such as kilopascal. Kilowatt Pascal. And kilopascal is denoted as kPa. Alright, that is what? Kilopascal. Please take note that 1 Pascal is equivalent to what? 1 Newton meter per second. Per meter, sorry. 1 Pascal is equivalent to what? 1 meter. That is 1 Newton per meter is equivalent to 1 Newton per meter. Take note of that. Another SI that is used in a pressure is we have atmosphere. Atmosphere is another SI unit, denoted as what? ATM. Alright, please take note that one atmosphere is equals to 1.037 times 10 to the power 5 Pascal. One atmosphere is equivalent to 1.037 times 10 to the power 5 Pascal. Take note of that, alright? Now, also note that another unit that can be used to denote pressure is what? Millimeter what? Mercury. Millimeter mercury. That is millimeter mercury. Please also note that 1 atm is equivalent to 760 millimeter mercury. 1 atm is equivalent to what? 760 millimeter mercury. Take note of that. It is very, very important. Now, another unit that can be used to denote ideal gas is Torr. That is Torr. Torr was discovered by Torricelli, and he also discovered barometer. Which is an instrument that is used to measure the pressure of what? A gas. Please take note of that. Also note that 1 atm is equivalent to what? 760 Torr. 1 atm is equivalent to what? 760 Torr. So these are the SI units of volume, alright, of a pressure, being the second variable used in what? Gases. Take note of that. So we shall look at the last one, which is temperature. Now, of course, you know that temperature means the degree of hotness or coldness of a given body. It means the degree of hotness or coldness of a given body, of course. Now, temperature has different SI units, all right? It is measured in degrees Celsius. It's measured in degree Celsius, all right? In Celsius scale, all right? In Celsius scale, we have the upper fixed point, which is 100 degrees Celsius, and this is known as what? The boiling point. This is known as what? The boiling point. While the lower point is called what? 0 degrees Celsius, and this is known as what? The freezing point. The freezing or ice point. Alright? The distance between the upper fixed point and the lower fixed point is called what? Fundamental interval. Fundamental interval, alright? And it's actually what? 100 degrees Celsius. The distance between the upper fixed point and the lower fixed point of a Celsius scale is called what? Fundamental interval, and it is what? 100 degrees Celsius. Take note of that. It is very, very important. Notes, please, notes. Volume and pressure have a direct impact on gas. Volume and pressure have direct impact on gas, which means that increase in pressure, increase in volume result in what? Decrease in pressure. Vice versa. Increase in volume will result in what? Decrease in pressure. But decrease in pressure result in what? Increase in what? Volume. Let me use a simple example to explain. If I have a larger container such as this, and I have a smaller one like this, I have gases distributed uniformly on the container, and these same gases are limited. They are found restricted. Now, owing to the fact that these gases are found in a bigger volume, in a bigger container or in a bigger volume, it means that the force they exert on the walls of this container, I can say, is moderate. All right, it is not quite high because the volume is what, large. But if I now reduce the volume of this container, such as this, what will happen? Don't you think that the pressure exerted by these gases on the wall of the container will increase? Definitely it will, because the gases that were found moving freely, they have now been reduced to a smaller what, volume. It means that they will exert what, a higher pressure. A good example is, for example, in a pipe. If you have a smaller pipe, if you have a smaller pipe and a larger pipe, as water pass through these pipes, which of them do you think pressure will be higher? It is a smaller pipe because it has what, a little lumen. It has a small volume, a small hole inside. That is why the pressure, that's why the water that passes through this small hole will move with a very high pressure. But the one that passes through this larger volume doesn't, right? Because of this large space found in it. So please, increase in volume result to decrease in pressure, then decrease in pressure result to what? Increase in volume. So we are done with three variables that are used to connote ideal gases. All right, so please, and yes, before I gave you this, I would have given us the meaning of gas. What is a gas? Gas is a substance that expand in order, I think I gave us, right? I don't know if I did. Gas is a substance that have the ability to expand in order to fill the container it is found uniformly. Yes, I think I gave us before, but I thought I did not give us, but I just remembered. So please take note of these variables. They are very, very important. Now, of course, we also have another scale called what? Kelvin scale. The units on this scale are called kelvins. That is big letter what? K. They are called what? Kelvins. On the Kelvin scale, there are 2 points. We have the first point called 0 point. This 0 point is called absolute zero. It's called absolute zero of what? Temperature. And it is a region where the lowest temperature is what? Attained. Which of the following is true about absolute zero of temperature? Please, it is a region where the lowest temperature is what? Attained. Okay. Now the second point is the fixed point. The fixed point is called triple point of temperature. As the name implies, triple, it tells you 3, right? So it is, it is a point where the 3 states of matter coexist. It is a point where solid, liquid, and gas coexist. That is why it's called what? Triple point. So these are the 3 variables that can be used in gases. Please, as you have watched, don't forget to subscribe so that when I upload the next video on this topic, you'll be notified by YouTube. Do have a wonderful day.